Hello everyone, I'm Amir Hossein. Welcome to a new training video about the RTTOV model. In this video, I will show you how different values of the input data can have different impacts on the RTTOV simulated radiation. The input data, as we discussed in earlier videos, can be atmospheric variables or aerosol concentrations. So let's start. First, navigate to the RTTOV test. And let me open a new tab, and in this new tab I go to test _ example.1. okay, in this directory, in the previous directory, in the first tab, as we discussed earlier, we have different applications that you can run them by some shell scripts. So we want to run this clear sky radiation simulation. So let me open it, and there is a check reference here. You don't need to check your output, so just disable it, just set it to 0, so you don't have to check the output of your simulation. Because this is just a training video, we just disable it. And I go to the second tab. Here we have some profile data or input data. This is the profile data that is used for the clear sky simulation, and also we have some aerosol concentration data. So just go to the first tab and just run this application forward G4tran. We don't want to change the input data, so we just use the default input data. I run it, and after the run is complete, if you list the files, you can see a new output file here. If I open it, you can see the simulated radiation values, such as calculated brightness, temperature, are listed here. Okay, let me have a copy of this file, of this output, into the copy directory. And now I open the profile.dat file, the input data, and I want to modify some values. The first variable is pressure levels, atmospheric pressure levels. We don't need to change it, but for each level we have some temperature and some water vapor profile. Let's increase the temperature here. So I just increase the temperature to 310. For some atmospheric pressure level. You don't need to do that for all variables. I just want to show you the impact of these changes on the outputs of the simulations. Okay, this is the last one, and go to water vapor profile, and let me increase it nearly 10 times. I actually increased the magnitude of the values almost 10 times. So it's okay, you don't need to do for all the atmospheric variables, the atmospheric levels, and ozone profiles is not used here. And for the surface values, we just leave it. We don't need to change it, just leave it. And I save it, and I go to the first tab and run it again. Run the application again. there are some warnings here. Let me check it. Okay, the output is has been created here, so these are not actually fatal errors, but just some warnings that can be logical because we increased water vapor 10 times, and that could have had some impact, some problems on the technical background of the model. But anyway, it could run, and we have a new output here, and this is the new output for the modified input data. So just let me open it, and I open a new tab, and here I open the previous output with the default input values. Here are the brightness, temperature, and this is also the brightness, temperature, and you can see that in the modified input data, in the simulation outputs with modified data, for the first wavelength, for the first band, the calculated brightness temperature is 294 Celsius, but the simulation output with the default value, that was 284. So 10 degrees is the difference between the two output values. And for the second wavelength, you can see the differences, 12 degrees here, and also for the third band you can see there's almost the same difference, 10 degrees in brightness, temperature. But you should notice that this situation cannot always happen. I mean, if the let's say the modification of the input data, if it has impact in a way that increased the first wavelength, the first simulated radiation, it can have decreasing effect on the second band, or decreasing effect on the third band. So it does not mean that it always has the same effect on all bands. Maybe in the first band the brightness temperature is decreased, the new brightness temperature, calculated brightness temperature is increased, or for the second band the brightness temperature can be decreased, or vice versa. So this was just I showed you actually how you can change the input data and see the outputs, simulation outputs. Now let me get back here and the second tab, and now I want to run the aerosol affected simulation. But first of all, just let's just run the model by the default values. The default values are here, aerosol profile, and you can see aerosol profile here. So I just run it. Before that, let me remove it. Okay, so just run aerosol example aerosol forward, G4 tran. G4 tran. Here you can see the output value. I copy this output value in the copy directory for the later, so later I can compare the new output with the old output. Now I open the aerosol profile and I change the values, the default values here. Let's say I put 1 here, so I increase it significantly, and here I also increase it significantly. Okay, that's okay. I save it and I run it again. Okay, so the previous file is overwritten, but since we have copied the previous file in the copy directory, we can compare the new output with the previous output. I open it, I go to the new tab, and I open the previous one. So if I compare them, you can see that for the first band that we increased the concentration of the aerosols. You can see that almost less than 1 degree is the difference between two simulations. But for the second band, there is no difference. That's interesting. For the third band, there is very little difference between the two outputs. So you can see that different concentrations, different aerosol species concentrations can have different impact on the wavelength. So the sensitivity of the wavelength to the aerosol or atmospheric variables are different.